developers can learn from it. Kind of a wide topic. Probably going to talk a little bit about the talk that you gave at VRLA about spatial computing and the body. Kind of going to go over the scientific principles behind that. Kind of giving an overview as to what we're going to talk about here. And as a bonus, we're going to throw in a little VR mixed reality action with the leap motion, actually. Well, I guess we won't be doing mixed reality, just kind of showing off the first-person view.
First-person view, yeah. But of a demo that I just finished a couple of weeks ago and that isn't out yet. So
that's right.
Exclusive.
So you guys get to see this for the first time, unveiled in VR on the ResearchVR podcast on Upload VR.
Mm-hmm.
Awesome.
So, yeah.
Hey, good to see you again.
Want me to start with the start of that long train of architecture background?
Exactly.
Okay.
And for our live viewers, you guys can write your comments and questions down below. Every 15 to 20 minutes, we'll basically stop and kind of do a Q&A. So just for the sake of not killing the conversation, we'll do it that way. So yeah, tell me a little bit about what you were doing before VR, and then how that switch happened to VR, and how that happened.
Totally. Yeah. So at school, I studied architecture.
Okay.
Did the 5-year pre-professional degree, the one that you're like, okay, I really want to be an architect. I don't want to do 4 years and 2 years. I just want to do 5 years,
all of them.
Full studio the whole time, which was awesome. But sort of the more I got into architecture, the more so I got into architecture because I liked making things. I liked building things, and architecture seemed like the study of the biggest thing that people ever build. So I was like, okay, this makes sense. But then as I got more into it, one of the things that I didn't like about the profession so much is that it takes millions of dollars, years, and hundreds of people to actually build a building, even a very small building or a very small space. There's a huge sort of gauntlet that you have to run through between having a concept for a space and then actually being able to step into that built space
and actually doing it.
Right.
Yeah.
And so that was one of the things that I was like, don't know if I have the patience to really multi-year see through something from a concept to an actual built space, and then all of the compromises you have to make throughout, from budgets and clients and building codes and all these other things.
Right.
And so
what initially attracted you to space in the first place?
So yeah, like I was saying, building things. I always liked making things, and it seemed like architecture was sort of the grown-up version of making big things. And so by the time I graduated, I had this conflict that I talk a bit about in the talk I gave at VRLA, between, on one hand, wanting to make physical things, and then knowing that making physical things is this really expensive endeavor, and that for the most part, you have to make tons of compromises, and the concept normally gets watered down until eventually ends up looking pretty similar.
Too many filters to go through, too many regulations and things to kind of get through. And
which I guess sounds like I'm just being whiny about I want to build my things. But at the time I was like, well, I could do residential architecture, or I could do installation-based stuff where the sort of the line between the concept and the actual finished product is much shorter. And I found that in architecture school, the projects that I enjoyed the most were the ones where I was working on the final thing directly. So we made one where we had a project where we had to build a park bench.
Okay. And
me and two other architecture students made this hobbit hole park bench that had grass that went over the top, and then a cubby hole that you could go inside. And that was probably my favorite project, because I was working on the final thing directly, not on models and drawings that were a proxy for a final project. And so that sort of thinking, once I got to the end of school and was figuring out what I wanted to do, saw virtual reality.
So did you, before virtual reality, or you used it as a tool, what were the tools you were using to really make these things come alive?
Yeah, so that's the other. So there's multifaceted part of architecture for me was making things, and then making things in VR is how I got there.
Right.
But in architecture itself, outside of the concepting, architecture is at its core the design of space. So when people think about architecture, they normally think about iconic buildings or structures or materials, or maybe even architects themselves.
Okay.
But really, all of architecture is to define, I think, and from what my teachers have taught me, is the definition of space. Because in a building like the one that we're in right now, these walls, the ceiling, this these big glass panes, none of that's actually what humans can use or occupy. What humans can use and occupy is the space that is defined by those elements. So architecture actually isn't about all of these concrete things.
Right.
It's about how those concrete things define the void, which is what people actually use.
That's interesting. So it's like it's a background foreground type of like visual illusion, right? Where you think the painting itself is like painting the background, but the subject itself is in the foreground and in the void that kind of comes. Do you know what I'm talking about? Those visual illusions.
Yeah. It's the result of the component parts, not the component parts themselves.
That, exactly.
But so it's both architecture is the definition of space, and then also the study of how humans perceive and experience that space, and how you can design spaces to have specific effects.
It's kind of like it's philosophy in a very living and like structural form, because it really defines like how you define what life is, how people should be interacting together, how spaces and personal spaces should be, separated, and actually actualizing it by building it. That's kind of how I saw architecture when I was first getting introduced.
Yeah, that's also, it's been like that for thousands of years, and I think in the last sort of 50, that's the importance of space and architecture has receded a bit as technology has risen. And so I would say, like, it used to be like exactly like you were saying, private and public space, workspaces, the third space between your home and your office, those sorts of things. And some places in the world are still as important and really like more important now. But I think with the advent of like smartphones, instead of like your work doesn't stay at your work anymore, your home isn't this domestic space anymore. All these definitions of space are sort of blurring together, because now we can do the same things in any space. So it was really interesting going to architecture school in like the late 2000s, 2000 aughts, whatever that decade is called.
Okay.
When like we were learning all this stuff about how historically all these spaces have been this or that, and at the same time I saw people who were just on their phones in spaces that were meant to be, like we would go visit churches and people would just be on their phones like scrolling through Twitter and things. Like it's a really strange mixture of the use of the space and then how it's being sort of confounded by like other people using
Do you think
things.
there's less of a less appreciation these days for the spaces that people are in, because we're less concerned about the actual space and more concerned about where we can go through our phones?
Definitely, yeah. I think it's when you're on your phone, I mean, and then that jumps very quickly to like augmented reality.
Right.
When you're on your phone, your conscious attention is on the stuff that's on your screen, and you're very much taken out of the space that you're actually in. And so it just makes sense that spaces don't have the same sort of profound effect on you when you can virtually have your attention be in another space. And that was one of the reasons also that I was like, okay, architecture, I think in some ways, I think architecture and its, if its primary thing is defining space and how people experience that space, that's being encroached upon by technology. There's other parts of architecture which are hugely relevant, and I'm really glad that tons of smart people are still working on it, with like sustainability and having buildings that actually help the planet rather than take away from it. All those things are super important. But on the space side and the design side, I think it's going to be super, super interesting with augmented reality.
Because I think that'll really shift the interest back, right, into actually taking your eyes up and kind of looking around, finding these hidden gems that you can really feature by using augmented reality. I guess tell me a little bit about how VR came into the play. Is it something that is very easily adopted in these schools now in terms of architecture, architectural design? Is it something, artists really picked up VR, I think, without any kind of hesitation, because it was almost like everything that they've ever wanted. And I can only imagine architects and even old school ones that, still got the pen and paper and ruler, which I'm sure you still should use these days. What's that been like? What do you think is coming?
Yeah, so super interestingly, the very first year of my 5-year architecture school, we only did graphite and slide rule drawing. So we literally had like the big slide rules, graphite. You had to like learn how to do line weights and everything. And then on this the first day of the second year, they were like, okay, now you can put that stuff away, and we're going to learn Rhino and Revit and Grasshopper and all of the computer tools that we're actually using in practice. Never did any of the drafting again. But it was really cool to learn because that's the history of it. And now a bunch of my friends who are in grad school, some of them like at Harvard GST and stuff, are using VR. I saw a couple of friends that were working at Morphosis, this like really famous architecture firm, showing the principles headsets. And yeah, they've been as quick to adopt it as artists. At the very base, outside of the actual design of the spaces, a lot of architecture is about using two-dimensional means to communicate three-dimensional ideas and spaces to people who don't necessarily think spatially or volumetrically. So if you're an architect, you need to convince a client to spend millions and millions of dollars to build your idea, and you have to use two-dimensional means, whether those are sections, plans, axonometric drawings, renderings, whatever it is, and physical models to say, hey, this is going to be awesome. Like, trust me.
Half the job is, it seems like, is you're working with non-experts or architecturally designed people.
It's not even experts, but people, like, some people think three-dimensionally and volumetrically, spatially easily.
What does that mean? What are you thinking in terms of like three-dimensional? Like, who am I if I don't know?
So some people some people are just really good with, say, navigation. Like if you can walk into a building and find a room, and then the next time you're there, know exactly how to get there or know exactly how to get out there. Some people just think spatially more easily, and some people,
your SLAM system basically works really well.
Exactly. Yeah. I mean, it's I don't know the neuroscience behind it, but some people it's just easier for them, and especially for if you see a plan or a section of a building, it's also a learned skill to see these lines and use those to create a mental model of what the three-dimensional space would be like. But for some people, that's a pretty big jump, and although try as they might and have an architect explain it to them, it's difficult for them to visualize what a space will be like from looking at a small two-dimensional drawing of it, or a rendering of it, or even a physical mock-up of it that's at a small scale. But all of that, what it's trying to do is use the means available to communicate what a one-to-one three-dimensional space would be like to someone else. With virtual reality, you just put a headset on, and you are now giving that person a one-to-one experience the same way they would have if the space was actually built, which is, I mean, that blows architecture wide open in terms of the presentation side of it. So I remember showing my my mentor at school the DK1 when I first got it, like a year after I graduated, and just he put it on and was just like, it just like didn't know what he had no idea about like Oculus and the resurgence of VR. And yeah, he just took it off and was like, well, this is going to change everything.
Wow.
Yep,
yeah.
It is.
Immediately kind of can see what's coming. Yeah, at Leap Motion, you're a developer, right? Or what's your title?
My title was developer evangelist, and now it's virtual reality designer, which is a lot closer to what I've actually been doing.
Awesome. So like you're bringing in a lot of design background that you had, obviously. And did you do much coding in architectural school? Did you even know Unity back then? What was that?
Yeah, so that transition, so finished architecture school, didn't know exactly what I wanted to do, and then saw two videos which ended up completely changing my life. One was the Oculus Kickstarter video, and then the other one was the first Leap Motion demo, back in the V1 days of the Leap being something that you put on your desktop and you told your hands over. And yeah, so I saw those, got a DK1, initially was just a really overzealous enthusiast, tried every DK1 demo that there was, then got my DK2, got the positional camera, which that changed everything, being able to actually move around, have parallax and stereo depth. I was like, okay, this is game changing. And then like a week later, after I got my DK2, Leap Motion had a 6-week game jam called the 3D Jam.
Was that the 2014 or
2014?
2014,
yeah. Had the 3D Jam, and brilliantly, they were like, if you enter this, we'll give you a Leap Motion. And I was like, so because at the time, you know, the only 6-DoF input was the Razer Hydra. There wasn't touch, there wasn't Vive yet, so there was no other 6-degree freedom input, and they were giving you a device for free. So I'm like, sure. I had downloaded Unity, but I hadn't really started doing anything. And no, didn't have any coding experience before that. Didn't have any development experience. And then so I got this device, and figured, okay, if you have your hands in virtual one, I've like tried the demos and like, this is amazing. Like once you have going from the DK1 with just rotational tracking to DK2, you can move your head around and you've got your hands in there. You can reach out and touch things. That was like, whoa, this is
Really,
totally
really
new. Yeah, so then I just quickly decided, okay, well, once you have your hands in here, what if you could have small objects which were fingertip sized that you could boop around in zero gravity. And so I made a little demo called Weightless, where you're in a space station and you're pushing objects around in zero gravity, and it works well for the limitations of the Leap without having haptic feedback, because when you tap something, it continues with the momentum that you gave it, so it gives you this like mental idea that, okay, that object's actually pseudo-real because it's reacting in a believable way to me.
Right.
Yeah, and I made that in Unity with Playmaker, which is this awesome tool that if you are... It is a visual scripting or finite state machine asset store plugin for Unity.
Nice.
That lets you, it's basically little pre-written snippets of code that you can link together in states with events that move you between them. So it's like, okay, this light is off. If the event happens that my finger goes through this trigger volume, then go to the on state.
It's like a blueprint for Unity.
Okay. It's a third-party blueprints for Unity, which is a little bit less in scope because Blueprints is fully integrated. But yeah, so made it with that.
So you start basically starting with with visual scripting to really understand the full, what you can do with this tool, and then kind of diving deeper into the code.
Yeah, it was the way that for me with coding, learning it separate from development was really hard because you didn't have that feedback loop of actually doing stuff. If I'm sitting at my desk and I have my headset and I'm like, okay, I want to press this button and turn a light on, and I can put my headset on and be in that space and then have the feedback of it actually working, that's a lot more motivating and satisfying for me than like learning the syntax of C# by itself.
But visual scripting is like the perfect entryway for someone. And that what visual scripting, again, or visual programming means, basically you don't write code, right? You're putting in dots and nodes and then connecting them with events and kind of having gates and if-then statements.
Yeah, right? It's like you're using variables, you're using methods and update loops and if-then stuff, but it's all presented in a way that is visual and has nice little lines that show you where things are happening, so you can understand it a lot better. For me, in a visual sense, rather than just having the syntax and getting errors when you've missed something.
So based on that, I want to show off what you've kind of been working on in Leap. We'll jump into the green screen here in just a second, and then we'll come back and talk about kind of architecture now using VR.
Sounds good.
Yeah, cool. Give us a second, guys. We're going to get set up here.
Jump over?
Yeah, let's get up over there. And Danny is lavalier. He's wearing it. Yeah, just turn it on. So yeah, so Martin actually, if you guys don't know from before, when he was talking about Leap Motion, he won one of the game jams, or probably a finalist with Weightless. That's kind of how I was introduced to him originally.
And then when you cut over to me, just hit space.
And it's a really cool space app. I'm actually gonna post the link for his talk, the VRLA talk, in the chat, so you can watch this later. Let's see what's up here. Cool. And turn on his lav channel. Don't go. Are you guys still here? Cool. All right, we can see your hands now.
Okay, so hit R in space one more time. Sorry, to just reset it. Thank you.
And so Leap Motion, for those of you guys who don't know what
R once and then space. Yeah, that's in the... Oh, not in the focus. Gotcha.
If Leap Motion is basically a device that you put on top of your headset that basically shoots infrared lasers to your hands.
Cool.
And you get to move it around and not have to wear a controller. Just introducing people. Cool.
Gotcha.
So yeah, why don't you kind of
explain what's happening?
Yeah.
Cool. So this is a new demo that I just finished called Mirrors. And the point of this demo is two things. One, body presence. So in this demo, you actually have a full upper body rigged avatar using IK. So it's leap driven on the hands, and then using IK on the shoulders and elbows. You can see in this reflection here that I've got a full upper body representation. So that's one thing, because Leap sort of brings more of your body into VR than most other inputs. And then the second thing is expressive communication. So if I was holding controllers, I'd probably have like stub doll hands that were moving between like a couple of preset poses. But with Leap, I have full articulation of my hands, so I can
see you talking with your hands a lot more.
Yeah,
with
you can
Leap.
like
That's
if
really
we were
cool.
in a social app right here, like I could communicate in a way that seems much more natural, and you could tell a lot more about me as a person by the way that I can gesture and articulate.
That's super cool.
And so this demo is called Mirrors. You're standing in this black cube, and you've got 4 mirrors around you, and in each mirror, you're going to get a different representation of yourself. So this first one is pretty much a heat map of speed. So if I stay still, I pretty much fade away. But then as I move, the particles color shift from like this.
Why don't you bring your hands closer to your face so we can
like
see
this.
it?
Here you
Yeah,
go.
there you go.
They color shift from purple all the way through to red. So you can see like my fingertips are moving the fastest if I move my whole hand.
So Northern Script is asking, what do the colors represent? That's the velocity, basically?
Exactly, yeah. It's velocity of each vertex, and that's determining the color of the particles. So it's a skin mesh particle emitter, and then you can see my head just shifts to red. So that's the first one, which is pretty much one-to-one with tracking and with my body. And then the second one,
that is so cool. Ooh.
this one is like a Human Torch type situation.
Whoa, so that really is like sense of speed, your flash.
Yeah, and you don't think you've got the audio on this, but you've got some like crackling fire, and when you move, it shifts the sound, stuff like that.
There we go. We got the sound on now.
There you go. Sort of a thing.
You have music playing in there?
Yeah, there's so each mirror has its own music. So basically, the demo was the point of it was body presence, so making you feel like your body's in here, and then getting people to dance around and express themselves. So I've got music that I thought was somewhat applicable to each.
This is world first, people. World first, exclusive.
Exclusive.
Only on the ResearchVR podcast. That is
And
pretty
then
exciting.
This guy, which is some nice flowy
Whoa.
piano music.
Oh, cool.
And then the other part of this demo is that on the front of the Vive here, I've got the new Leap Motion sensor, which is designed specifically for being embedded in mobile headsets that are going to come out in the future.
Can we show that?
I think you can, yeah. But the point of it is that it has a much wider field of view than the current Leap Motion. So the cameras on here are 180 by 180. So in the mirror, because the Vive headset is only about 110 degrees the field of view, you can't tell how far the hands get tracked out unless you're looking in a mirror. So in first person, like it's beyond where I can see them, but in the mirror you can see that it's still tracking my hands like way out here.
So we're currently looking at your headset, actually looking at the Leap.
Oh, right on the front here.
On top, yeah.
So this isn't going to be sold to consumers. It's only being sold to companies who are making mobile headsets to be embedded in mobile headsets that come out in the future.
Cool.
But
and then now looking at your headset view.
Right. So you can see my hands here, and then as I bring them further apart, now they're outside of my field of view in first person, but in the mirror you can see that they're still tracking way out here.
There you go.
So you can see that.
Oh, cool. Whoa.
Which
yeah,
is,
that is super wide, actually.
Yeah, which is a huge improvement in terms of the usable area of tracking space is now way out here.
That's awesome. People are seeming very happy and shocked.
All right, and then the last representation is this one, which is kind of this crazy, just throw stuff up. So if you move really slowly, you can see that's like by flicking my fingers, I can have these crazy amount of
That's
particles.
cool.
Yeah.
How how did you make this? This is obviously using Leap Motion. I think anyone can do this already with the Leap Motion that they have. Obviously, won't be able to do it at just as wide, but
yeah. So I mean, you can do. This demo will be on the gallery on our website.
Cool.
Probably next week.
Oh wow, cool.
So people will just be able to download it and try it. at home.
So yeah, you guys should go to the Leap Motion website. They have a big gallery up there that you've shown off a few of the other experiences that people have made, including you guys. That's really cool. Thank you for that, Martin.
Yeah.
Round of applause. That actually, that I feel like that would tie in so well with like the Wave VR, with like Audio Shield, with soundboxing, a few of these like really music and rhythm oriented experiences, because it's all about the articulation that you can do, and obviously you wouldn't be able to do that with a joystick or a mouse, and seeing your fingers flickering and like that sending off these crazy webs.
So yeah, I talk about that a lot in the talk. There's two sides to the spatial computing thing that I'm
Sorry,
talking
wasn't that
about.
cool, guys? That was really awesome. I just want to acknowledge that just happened. That was really cool. Okay.
So I don't know where we left off. Am I talking about Leap?
Yeah.
Weightless did some stuff.
That's right.
Working at Leap now as a
Right.
designer. So
By the way, that's a cool story that you basically participated in one of their like hackathons, let's say like online hackathons called Game Jams, and then they really liked your stuff enough that they're like, hey, you should come work here, right?
Yeah,
kind of.
It's a strange story for getting a job. I sort of argued that having more example, we're in such a new space.
Right.
In terms of the platforms, in terms of virtual reality, mixed reality, augmented reality, but especially in terms of input, it still is very much the Wild West of inputs. We've got tracked ones have finally become sort of a standard, but
there's still Kickstarters coming up every week, basically.
People are making gloves, treadmills, wearables, armbands. So I think the things that are gonna stick around, and this is to do with the body being the interface, I think, of the future of these things, are eyes and hands are how we interact with the real world most of the day, all the time. And so by tracking those things, I think that is a very solid base for future inputs in VR, AR. So in my talk, I talk about spatial computing being what I think is sort of VR, AR, MR, XR, all these different terminologies for the same thing, which is using the space around us as a medium to interact with technology, which is what I see all of these platforms as having. The commonality of the space around us has now become something that we can use to interact with technology. And so on the two sides of that, one is we have all of this, we have thousands of years of the study of how humans use spaces and objects, and all of that stuff is now relevant to spatial computing, because we're perceiving and interacting with objects the same way that we perceive and interact with spaces and physical objects. Although there are some caveats to that of like you can put your hand through a table now. So does that change how a table should be designed, how it should be?
Or that you have
experience.
Instead of people that you're talking to directly, it's indirectly being communicated by like thousands of other people, and how do you represent them within a space that you can understand? I think, yeah, absolutely, that this is blowing open doors to your brain that we haven't been able to do. And a lot of, living and understanding how houses work and how they affect your psychology, I think, is now going to be applicable to apps and user experience flows that are going to be, things that you're going to want to design for. It's not just nav bars and icons that you really have to think about, or colors and notification sounds. It's holy crap, like you're completely controlling the space that they're in, and what colors do you use on the walls? What happens when your hands do go through a wall?
So yeah, I would say that even people saying like, oh, we don't have to think about, don't start from two-dimensional UIs and windows, icons, menus, and pointers and stuff. Like, of course not. Like you're putting on a headset, you're hijacking a person's perceptual system. They're experiencing a virtual space and virtual objects the exact same way that they, in terms of visual perception at least, the exact same way that they would experience a virtual, a real space or a real object. And so we have thousands of years of study of these things. There's so much to be learned from those things that can be directly applied today. I broke down architectures as having into 5 sort of really core ideas that you can apply to spaces that you design for virtual reality very easily. The first of which is like form and space. So like the very basics of architecture is that there is form, there's materials, there's things that define space, and then there's the void of the space that those things define.
Okay.
And so if
So the 1 and the 0, like the wall and the not wall.
exactly. So like in Antelope Canyon, you know, that like beautiful wave. So that thing is a great example of mass and void, in that they are the two sides of the same coin. Like you need mass in order to define void, and without the void, you can't define mass. And so it's like this inherent relationship between definition of space and the space that's being defined. And so that just thinking about that for like virtual spaces, starting from that rather than starting with, oh, I want to make a space station, so like I'm going to make it look like a space station. Thinking about spaces from form and void, then the next thing I would say would be like light. Light is probably so you only really perceive a space by light bouncing around the room and then entering your eye. So the same space lit differently will have a completely different effect on a person. And in real architecture, in physical architecture, light is this really predictable thing. Like we know where the sun is going to rise and where it's going to set and how it's going to move through the sky. And so we have to design our spaces in such an orientation, in such a way that it takes advantage of the light, given that we know what's happening. But in virtual architecture, you can control the light. You can control not only the sun, you can create lighting situations that wouldn't exist in the real world because of cost or because of physics or because of whatever. You can use light to direct attention. You can do crazy amount of stuff with light.
You know, I've ever since like thinking about that a lot more, even going back to traditional video games, I'm starting to realize lighting is such a big factor even in there. Just for guiding you through a mission, guiding you through a level, how doors and entry and hallways are lit in a certain way. And I think a lot of that you're saying translates into the apps and the products that are being made in VR to
totally. I mean, it's so architecture and industrial design I think have been used in 3D video games for like decades at this point, but for the most part they've been used as backgrounds and props that are serving the gameplay. So definitely, like I know an architect who's now a level designer, and there's like a lot of crossover there because when you're designing a space, you can design it very directionally, so that you're implying a direction just from the forms, the shapes, how they relate to each other. But in a lot of instances, it's a nav mesh or a level for a platformer, not necessarily architecture in the same way that it is in the real world, because you're not experiencing the spaces as you would in the real world. You're experiencing them as you're an avatar that's on a screen that needs to navigate this space. So it's a different application of architecture, whereas in VR now, you're experiencing the space one-to-one. It's literally the exact same thing as if you were actually in a space.
And I think in a video game, you're mostly kind of strafing and looking around. You don't do much up and down. Like that's really when you're like, oh, I want to explore space and look up. Yeah. Apart from, I think in VR, it's way different.
It's also like that's a really good point. Is that in a regular like first-person shooter, you're using the right control stick to direct your gaze, and so it's also an extra abstraction. Like if you want to look up, you have to consciously flick up, whereas if you have an inkling of looking up in the real world, you just do that, and it's one-to-one. There's no like second degree motion sort of. Just made that
That's
up.
right. I want to put this out there. Start writing your questions now. We'll probably do a little Q&A in 5 minutes. I'll let it pile up, and we'll go through the good stuff.
Sounds good.
That's awesome, man. I mean, what's kind of on the next foreground that on the forefront that we should be looking out for in terms of coming out from Leap? You said, I mean, you were just showing off that there's a new mobile sensor in there.
Yeah.
I just tried it out. Actually, I tried out the Qualcomm all-in-one headset with the Leap attached to it, and it worked. I was walking around inside out tracking. My fingers were tracking in there. I was playing the blocks demo. So I'm guessing that probably some developments on that end.
Yeah. So
and you really think mobile is going to benefit from hands the most because you're walking around, you don't want to carry controllers.
Exactly, yeah. So on the flip side of you experience space and objects the same way that you would in the real world, is that it's clear to me at least that if you're experiencing spaces and objects the same way you do in the real world, then you're probably going to want to interact with them similarly to how you interact with spaces and objects in the real world. And the way that we do that is by using our bodies. Like most of the day, you're using your hands to interact with objects, and you're also using your eyes to interact with objects. And then if you want to do something, if you want to do a specific task, you'll pick up a tool and then use that tool. So I think at a base level, I think in the next generation of headsets in the near future, hand tracking and eye tracking are going to become just standard.
Very
the same
standard,
way that
yeah.
positional tracking is becoming standard and probably should be at this point. And we're going to just see those as like, of course, every headset has eye tracking and hand tracking. And then for specific tasks, like if you're shooting something, I always want to have something in my hand and a trigger to pull. If I want to be painting something and have really precise input, I probably want something that's similar to a paintbrush. And so you add inputs for the specific use case. But so with that as a base, obviously
You're saying you can do a lot more things naturally with eyes and hands but there are very specific things that would be very much improved by having a tool in your hand, right?
I think it's just it's easy to look at the real world and then bring that into VR as a basis for interactions. There are things which are simple, and like for most actions that are just menu based or something, I think we're probably going to get some. I'm sure like iFluence is a company that Google bought recently. I still don't know how they do it, but they have a demo of like being able to
Typing.
not only select. I mean, selection through through gaze tracking is obvious. It's like, where are you looking? But then they also have a demo of being able to confirm a selection. So being actually able to click on a menu thing using just your eyes, and it's not blinking, it's something else. Something, I don't know about that. If you got some inside info. But so I think for like the very subtle interactions of like menu navigation and stuff, I think we're just going to go to eyes for that, because you probably don't want to do voice like on a bus or something. We like confirm loudly, or even do this maybe. If you can do it on a subtle level with eyes, I think that'll be. I think in general, the more subtle you can have of an interaction and it have the effect that you want, that's what we generally will go to.
I agree. Yeah.
And then so on a similar level, being able to manipulate objects in 3 dimensions and stuff like that, your hands are the best at it, and they're also incredibly more intricate and complex than a tool would be. But then for specific applications where, especially in virtual reality, you're using a tool, you're going to want to use a tool in your hand. I think right now we're just seeing sort of like weird mixes of that sort of stuff, like in Job Simulator or other games where you're holding a controller, but you're being shown an avatar's hand, and then when you go to pick up an object, they do this thing where, I mean, I understand why you don't want to have all these animations for picking up objects, but you grab something and your hand disappears and now you're just holding the object. These are all very strange things that we're kind of just accepting, because
and people do comment about those things, you know, like where are my hands, you know, like there's a lot of that. And even though a year and a half ago, I'd say the first time user experience with like a DK2 and a Leap, you know, that I'd say that was very common for most people to have. You'd put it on to someone, they'll be looking at their hands and arms and they can see the full thing. I think that was a lot more compelling of a first time experience and a lot wowing than having to teach someone how to hold buttons and triggers, and it gets complicated.
We're in a very weird stage where we're introducing people to these things for the first time, and you look around and you're like, whoa, I can look anywhere. And some people will look at their hands and then be like, oh, I don't have hands. Sure. Where in like 5 years, we're going to be like, what? How did we not have our hands with us? How did we not have our bodies with us in VR? It's all transitioning. But to get back to the point at the very start of this conversation was eye tracking and hand tracking, I think are going to be standard. And obviously for mass mainstream adoption of spatial computing platforms like VR and especially AR, which is all going to be mobile, the devices themselves are going to have to become all-in-one devices, and the form factor is going to have to shrink. Right. So like HoloLens, ODG's R9, Meta headset, Magic Leap, if that ever comes out, like all of these devices are the first of those kinds, which I think is going to be like Vive and wearing a sub pack and wearing a full haptic suit. When I'm at home, sure, I want to do that. I want the most immersion possible.
Right.
But in terms of this becoming something that these platforms becoming something that eventually replaces smartphones, they need to be small and they need to be all-in-one. You're not going to put it on and then pull out your gloves or pull out your Wii Nunchuck controllers. They need to be all-in-one devices. And instead of just being able to track objects that our bodies are manipulating, I think that they're going to need to be able to track our bodies directly.
Yeah, rather than a complication along the way, or
rather than just an extra thing. Like rather than the head being tracked by the headset is one thing, but then needing to wear gloves or rings or armbands or whatever else to track your body, I think that the most
it's just more friction points.
It's 1 degree removed from the actual articulation that your body is capable of.
Your fingers are very dexterous. They can do a lot.
Yeah, exactly. If we can directly track your body, that's literally the most input until we get to like brain-computer interfaces that your body is capable of. You are this three-dimensional human being. That should be what the input is for this spatial computing platform.
And I'd say even more so when it comes to like social communication. When I was looking at your mirrored subject in VR, and when you're moving your hands and articulating when you're speaking, that was a lot more convincing than having just 3 points of tracking your controllers in your head. I'd say a lot more body language kind of comes through that way as well. Is that something that you use with your team at all when if you guys are having VR meetings, you all have leap motions? Like, do you see that kind of coming through already, or are you waiting for more?
No, yeah. So I think you actually interviewed Alex Colgan, our head writer at Leap. And he lives in Nova Scotia in Canada. And so normally we just dial him into meetings or Skype him in. But we've been looking at using social platforms like Big Screen and AltSpace VR.
That's right. They both support it, right?
They both have Leap support, yeah. So that we can be in a room together and he can gesture and articulate. And I've never met Alex, but when I see him in VR, it's the closest to actually seeing him in person.
And I bet if you were to meet him in person and without like seeing his face, you'd still be able to recognize him based on like his gestures and his movement if you spent enough time with him in VR, right? Like I think there's a lot of really interesting things that arise from there where it's almost like it's fraud detection by itself. you don't know the person you're talking to is that person because they move like that person.
It's gonna get super interesting, I think, like right now with chatbots.
Yeah.
It's you can mess them up pretty quick because it's all like just syntax. You write some word like that doesn't really make sense. If in the future we have chatbots who are also using maybe some like machine learned neural net like gesture stuff, where they're mixing and matching tracking data from other people, and so you're in VR and you come up to someone and they have like better voice capabilities and just are saying something and then are gesturing like this, it's gonna be really hard to tell like what's a human and what's not a human. I think.
Yeah, that's the Turing test, right? Yeah, but
if you have the body language, then that brings it like it's not just is this text response to me correct or not? You've got all these other things that are like that looks like a person to me, and you
and having it dynamically change per person per culture, I think would be definitely interesting. Otherwise, there are a lot of gestures that are obviously universal, but there are very culturally and specific things that I grew up actually learning that like doing one nod up means no, like no.
That's confusing.
Like that's a sup type of thing in America, right? Like, but it's like this is no and this is yes, but this is also no. Like just one up.
So if I do this to you, you do this back to me, and you're like, no. I'll think. I'm gonna think that you're gonna be like, yeah. So it doesn't matter. Fine, that's fine.
That's right. So it's interesting. I'm sure you guys are thinking about all of these elements and how the body is really translated into VR.
Yeah. So so on that point, there's the social gestural stuff. I'd say there's like 3 or 4 different facets to it being useful to just jump on real quick.
Okay.
1, social gestural communication expressiveness. 2, removing abstraction. So like you were saying, when people grab a controller, when you put on a headset and you give someone a controller and they're not a gamer, they have to get used to pressing buttons, joysticks, whatever else is on there, and they don't have experience with that maybe and are blindfolded, so they have to learn that while they can't see their hands.
Yeah.
If you, like in blocks, you put on the headset, you have a block in front of you, you reach out, you grab the block, you throw the block, you push the block. You don't need to be told how to do those actions. It's not like button combination. It's the same way that you use your body in the real world. So the lack of abstraction. And then another one that when you were talking about a second ago, virtual spaces where you have a wall and you can like put your head through it, you can put your hand through it. We've seen some like cool things where, I mean, not cool things, but smart things that when you put your head close to a wall, like it blacks out or it like
X-rays
or X-rays or whatever. There's some really cool stuff that Colin Northway and Kabibo were working on, where you put your head through a wall and there's like a whole nother like sign distance field dimension on the other side. But another really cool thing with hands is that when in the mirrors demo, when you touch a mirror, there's like a water ripple simulation going on. And if you had a controller and you were poking that mirror, it would be cool, but it would be a little unsatisfying because you're using like a stick to poke a virtual material.
Sure.
Whereas if you have your hands, you can run your hands over it,
Right.
and you feel sort of this like virtual materiality. I think virtual materiality is going to be a really important, cool subset of design where people will be designing objects that will react to you in a way that's not real, because we don't have reactive surfaces that much in the real world, but in ways that
Visually-
are really satisfying.
Visually react to you mean, and that
Visual, yeah.
signifying
So
something?
I made another demo called Mr. Material that was all about that, where it's this little interactive character who leads you through a bunch of different virtual materialities.
Okay.
So there's one of videos are not online of that one yet,
Okay.
unfortunately.
Can't search
There's,
it.
there's some on my Twitter. But not full videos of it posted yet. Where like you have a squishy ball, and when you grab it, because your hands are going to go through the perimeter of the ball, it deforms so that it still is in your grasp. Same thing with Kabibo has done a bunch of stuff with this. Like all of Kabibo's stuff is virtual materiality,
Yeah.
I would say,
Yeah.
where everything reacts to your touch. And the more virtual spaces react to you and your interactions, the more they feel real, as opposed to just static geometry.
Yeah, and I think it's just like your brain trying to figure out the physics of that world, and that will make you spend more time in there. I think like I've spent a lot of time in blocks, especially when it first came out, and more than any other VR app, because you could do more, and I say that with quotations. Like there's very little you can do, but you can do a ton.
Exactly. If you were to describe it in terms of like game mechanics, it would be create a
Right. If you write it out on a piece of paper of what it is.
the feature set
feature
of
of a
blocks
game.
is create a block, push blocks around, grab throw blocks, and change which kind of shape you're making. Which sounds like game of the year. Like it's blowing the roof off VR games.
Yeah.
But because within that set of things, there is this infinite possibility of flicking an object, like rolling your hand over it, caressing it, stacking objects up, trying to juggle. Like all of these things are physical actions that you could do with real objects, but because you can do them with virtual objects, and because you can make them appear out of thin air, which seems like magic, like that's what makes it amazing. Whereas if you were to say, oh, you have a space game and you can shoot blasters and railguns, and the actual mechanics are pressing a trigger on a controller, that's actually a much more limited mechanical input feature set than the complexity of hands.
Awesome. I want to do a little Q&A here.
Yeah, let's
I feel
do it.
I've been ignoring people. Hello, everybody. We are on live on like a bunch of different platforms. Let's see. I had a few lined up here. Adam Green, thank you for helping me moderate. Let's see. Raj, noob question. Would you talk about the programming languages one needs to learn to pick up AR, VR, MR? I'd say, well, you need to know spatial, or you need to know Unity.
I mean,
learn a
so
little
I would
about
say
C#
if you're totally new to development, Unity and Unreal, those are the main choice that you got to make. Unity is a lot more beginner friendly in that it has a ton of resources and tutorials, because it's been targeted towards hobbyist and independent people for a long time.
Sure.
So there's a ton of for tutorials and questions that you have, there's a ton of resources. For scripting, it's in C# or in Java, but there's also Playmaker, which is like we were talking about, an asset that you buy on the Unity asset store. It's a
Right.
third-party thing that lets you do stuff visually. That's the route I went. On the other side, there's Unreal, which is also free now, and Unity's sort of more general purpose. People use it for a bunch of different things.
Yeah.
Unreal is pretty focused on games, because it's traditionally been like a AAA games
Right.
game engine. But they have blueprints integrated from Unreal themselves, so it's not a third-party thing. And blueprints is integrated completely, meaning that like anything that you would
everything.
want to do,
Right.
you could do with blueprints instead. And Unreal is C+ instead of C#.
C++?
C++.
Okay.
That's one.
2 pluses.
That's one.
Plus iteration.
Yeah, so both of them are, and
Awesome.
just they're free, and you can watch tutorials online, which is how I taught myself. So do it.
Do it, dude. That's
Do it.
if
It's
you learned,
available.
then you can learn
We
as
live in
well.
the time when you can just learn stuff from the internet
That's
for
right.
free.
Abby Albright, what's up, Abby? She's asking, what does he think about building rooms inside of a practically infinite environment in the virtual world? I.e., why are we making rooms instead of keeping people in a very open space? I guess that's an interesting question, right? If you have infinite space in VR, why constrain someone into a room? Is there an actual architectural and / psychological reason why you don't actually want to do that? Because I think they totally can be.
So the question is, why are we even making spaces when it could just be an
Why are you
infinite
confining
void?
someone in VR? Yeah.
Yeah. So
From a designer's perspective, like why would you want to do that?
So the when I was laying out some architectural core principles,
I think we got through like one.
We got through two. The first
Two.
one was form and space, so mass and void, then light, and then the third one was scale. So scale is another thing that's like unique to spatial computing platforms in VR and AR. In that, if you look at a the blue, the whale intro thing.
Yep.
If you did that, if you look at that on a screen, you're like, all right, there's a whale there, cool. If you do it in VR, you're like, whoa, that whale is huge. That's the hugest thing I've ever seen. And the reason that is because you have a sense of scale in VR because you look down, you know how big you are as a human, and then you can compare that to how big something else is. So, scale in space in spatial design is super important. You can have spaces that feel inviting and warm because the elements in the space are designed with reference to the human scale. So if you're in like a wood cabin or something and the benches are all at human waist height, the windows are at eye level, if everything references your size, then it feels like it was built for you. On the other side, if you go to like a Roman temple or like St. Peter's Basilica, they're huge spaces that none of the elements are sized to an individual. And so what that does psychologically is gives you the sense that this is a monumental space that's indifferent to the individual. And so sometimes some people also have like, agoraphobia is literally like you don't want to leave your house because the world's too big and it's too open. So psychologically, it has an effect on you if you're in a small space or if you're in an empty void. Just stammered a lot there. The design of any space is any element in the design of a space is going to have an effect on a person. If you start with a completely black, featureless void, anything you add is going to change the feel of that space. And so it's important to think about like what is the intent of any change.
Change the point of a space of why you're there. What are you trying?
The point of it one, but the feeling of it. Like if you're in a room, that's going to feel different to if you're in an endless void.
You wouldn't want your home page, your Oculus Home or whatever, to be a Roman Catholic Colosseum or something, right? Because like that's not a home.
You could be. I mean, maybe that's what the feeling of that is what you like. I'm not saying one's better than the other. I'm just saying that they're different feelings.
Yeah. Cool. I like that. Abby Munoz is saying, do you know any of the architecture studios that are incorporating VR into their practice? If so, what type of projects are they working on?
So yeah, I have friends working at some firms that I know are using virtual reality. I think for the most part they're using it for presentation, so that you can show a space to someone one-to-one. Yeah. I know a couple of people are using it too to mock up spaces, because normally when you're designing or concepting a space, you would do some two-dimensional drawings, some three-dimensional drawings, and some physical models and massing voids, trying to figure out how the spaces relate to each other. Yeah. But making physical models sucks a lot of the time because you can't make it quicker. Yeah. You just have to like cut things and glue things, and I've held super glued objects together and like my fingers super glued together for years and cutting myself with little like X-Acto knives. Right. And so instead, if you can, in like Gravity Sketch is a really good one. You can just quickly extrude three-dimensional forms like the same way you would in SketchUp. And quickly get a sense of how spaces appear. And then also, it's not just a model that's at 100-to-1 scale. You can press a button and now you're at scale 1-to-1 in that space. Right. So I think it's at the moment being used for presentation a lot, because you can take Revit models and other BIM models and bring them into Unity or whatever and then just show them. But I think very quickly it's going to become used in the entire production of architecture.
Got it. Awesome. I think there's a lot of potential there, and it makes sense starting from the presentation side because the tools are being developed, but things like Gravity Sketch really do make it easier to just prototype quickly and run. I know there's even ResearchVR that is a SketchUp Sketch 3D plugin.
ResearchVR, they're doing a lot of presentation stuff as well. There's a bunch of companies who are working on it. I think like Autodesk and like the big players in these spaces are also working on making VR native tools, but I think they're taking a bit longer to do it. Sure. I don't know how it's all going to shake out, but
soon enough.
Yep, we'll see.
Let's see. Andrea Box. What do you think about VR games versus VR tech demos? Personally, I think there are a few VR games and not enough, and the other things are kind of like short experiences. Would you consider blocks to be a game or a demo?
No, it's actually absolutely a demo. I think
Yeah.
most things right now are demos.
Mm-hmm.
But I mean, it's part and parcel of where we are with the platforms.
Sure.
At the true games are tens, hundreds of millions of dollar productions, and with the user base of VR being in the hundreds of thousands, just the numbers don't work for having full true games. That's why like Fallout 4 is going to be probably one of the first like true games, because it was built for not VR, and now they've ported it over.
Yeah.
But I think as more people buy VR headsets, there's going to be more games, and then also as mobile starts taking off, there's going to be more true games on mobile.
Right.
Hopefully, which will have better input rather than gaze-based.
But also, I think the argument can be made with like mobile itself and how that kind of created an entire genres, and a different industry of how games are delivered, how they're played. I mean, the freemium model even didn't exist before mobile, and so maybe we'll see a similar comparison happening with.
Totally, I'm not sure. I mean, there's so many different ways it could go from like episodic to freemium to early access, like the crowdfunding. In the last like 10 years, video games themselves have gone through so many different changes for how they're funded and how they're made. I think it's super early in these platforms to say like how it's going to work out. But I mean, the reason that we haven't seen, I agree with you, the person that asked the question. Totally, there's way more demos than there are games. But it's just need more people. Keep telling people to buy headsets, and then we'll eventually have more games.
Keep playing VR, keep trying VR, keep buying them. Let's see. Do you think? Oh, actually, this is something that we barely even touched, but augmented reality and architecture, or in terms of like even on the construction end, before you get the things approved in VR, you design it in VR, you present it in VR. Then it's actually as it's being built using AR, or after it's built using AR. I think that's a whole other podcast that I'd love to do.
Touch on that though.
Yeah.
There's a designer who was also an architect called Kiichi Matsuda, and he, you can check this out online, throw out the link, something called Hyperreality. He has a film series where he has this like, it's first person from a person who's in a near future where mature AR is everywhere. It's kind of dystopic in that everything is covered in sort of spam ads and notifications. I hope that's not the future that we're going into. But I mean, that's something that I think is definitely going to happen, is that in the future, like what we were saying with when you go into spaces now, people don't necessarily experience them the same way because they're more focused on the device in their hands and the technology and the virtual life that they're living more so than the physical space that they're in. With AR, all of that information, instead of being on your phone, is now going to be overlaid in the real world. And I think that's going to have a huge effect, one, on how smart architects design future spaces, such that there are, I think there's
white panels.
Yeah, I just think there's going to be a lot of white walls that are blank, and the ornamentation and the decoration and the character of the space is going to come through virtual skinning, because one, it's so cheap. You could change every day of the week. You could have a completely different interior to a space that, and also be customized to each individual. Like we can both be wearing AR headsets, and I could like wood trim, and you could like the brick exposed look, and we could each have our own skins. It's the same way as that the internet is now becoming this like. When I look at my newsfeed, when I look at Reddit, when I look at Twitch or YouTube, it's all customized to me. Yeah. That sort of customization with the underdriving factor of targeted consumer ads, which pays for everything, is, I think, going to leak out into the real world very quickly with AR.
I think especially for retail spaces, that makes a lot of sense, or spaces that you have to pay to actually monetize, or and they're thinking of the bottom line. If it's going to be cheaper to do it this way, it's probably going to go that way. But I don't think that's going to be the full. Like, I don't think all architecture will be, black and white. I think there's going to be, the beauty of it is really going to come out when you have intricate things built into the wall that then suddenly with AR like come alive and come out. And, like if you want to spend money on building something beautiful for without a headset, but augmented with a headset on top, I think that could be really interesting.
I think there's going to be
just like art, right? Like if you can augment this painting behind us right now, it's a beautiful painting without a headset, but with a headset, you could even give it 1.5 X layer on top of this. So I don't know. I think there's. I don't want to scare people away from where architecture is going to be going if we don't need to build every single, chisel every single thing out of the wall, and it can be augmented.
I think the base stuff, the infrastructure, like a building's got to stand up. It's got to have plumbing and cooling and all those things.
Sure.
But I think the physical, I think really luxury spaces are going to be able to spend money on physical ornamentation. But I think the sort of middle class of architecture that's being built, it's just going to be cheaper for them to have the non-invasive white or blank, and then reskin it with a lot of digital stuff, because it's just way cheaper to have virtual images than it is to build real things, which is a full circle around to me jumping out of architecture.
Yeah, that's cool. So I want to, how can people reach you? How can people find your work?
Twitter is probably the best. I need to tweet more. But yeah, I'm on Twitter at Mr. Schubert, Schubert.
Mr. Schubert.
Yep.
Mr. Schubert. Leap Motion, you guys can find Leap Motion at leapmotion.com to make the cool hand tracking demo. If you didn't see the VR demo that we did earlier, this video will also be up on YouTube, and so you can go and check it out there. You should watch it afterwards. It looked really cool.
Sweet, I'm glad.
It's called Mirrors.
It's called Mirrors. Should be on the gallery on our website pretty soon. If you have a Leap, you'll be able to download it and use it on a Rift or a Vive.
Coming out next week or so.
Coming out, yeah. A little demo.
Dropping the mixtape next week, right?
VR mixtapes, I think that's the thing.
That's what's coming. All right, guys. Thank you again for joining, watching, commenting, and asking questions. Hope you're learning just as much as I am about the topics that we cover here. Next week, we'll announce, hopefully a little bit ahead of schedule, and we always keep it real on Thursdays. That's how we do it. All right. Thank you, Martin, for being here. Thank you, everybody, again, and we'll see you next week.